Good morning, my name's Don and I'm going to show you a very simple, easy to make, do-it-yourself 2-inch PVC pipe gold trap. This thing is incredibly effective. It will get virtually 99% of the gold above 40 mesh and a very large percentage, probably 95+% of the gold below 50 mesh. Very easy to operate. I'm going to show you in a second part after I shoot this on the driveway. I'm going to go to a friend's house and we're going to run this thing and we're going to do a comparison to the gold trap and see if any of the sediments that are discharged by this end up in the gold trap, just for a little proof of the pudding. I've got it set up with some recirculating tubs where the upper tub collects the sediments. It drains into the lower tub. The classifier there is just to collect the organics to keep it from trashing the pump. What you have on this PVC pipe, there's two hopper types. You can either use the water bottle with a piece of 2-inch PVC epoxy glued to the neck, or you can put an RV fitting onto a bucket and then just use the 2-inch by 3-inch rubber coupling to attach to the 2-inch neck. I'll go ahead and assemble the hopper to the end of the PVC gold trap so you can get a feeling for how it looks up during how it would be set up for actual operating conditions, which will come shortly. Let me just go ahead and take a minute and connect. I'm going to go ahead and just set up. As you can see, it's just a neck on a 5-gallon water jug that I cut the threaded part of the neck off, and then I had to hollow out a little bit with a file the interior diameter of that 2-inch tube PVC pipe to accept the neck. The neck of the water bottle had about a 2.1 outside diameter, and the inside diameter is 2-inch on the PVC pipe naturally, so I had to do a little filing to make enough room to epoxy glue the PVC pipe onto the neck of the water bottle. Anyway, just put and I'll tighten these down in actual operations, and that just fits over this. The inlet of the pump, outlet of the pump, just goes into the water bottle. During operating modes, you'll see later on, you want a working fluid level up here to make sure you don't get any air in your mixing water. You want the static, when you shut the pump down, fluid level just to be in the very bottom of the water jug or the bucket. Then you would just move this for clean out purposes. If you want to look, I've got just a 2-inch rubber cap over the end of a little short nipple of 2-inch pipe sticking out of that sanitary tee, and this rubber coupling allows me to just rotate the upper part of the discharge depending on how I have my tub set up. It may be different depending on how things look out in the field. But basically that just sets up like that. You then just, the mortar mixing tub is very easy. I just take a scoop or a coal shovel and just scoop the sediments out periodically, because in a recirculating system, naturally every gallon of sediment in, you got to take one out. Again, just to show you, if you wanted to do the bucket, if you don't have access to the 5-gallon water jugs with an adequate neck, you can buy a 3x2 rubber repair coupling, glue that down. You need to use either a JB plastic weld glue, or this is an E6000, kind of like a goop. It's hard to find cements that will stick plastic to plastic, but that would be the way to just make an alternative bucket hopper. Water and dirt are in this top hopper. You just slowly scoop in your minus 1/4-inch mesh material. Everything's discharged here. At the end of the day, you just drain off the tubing, pull the cap off the plug, and you got your concentrates. Anyway, I'm going to shut down here. I just wanted to show you a nice clear picture set up in my garage. Now I'm going to go to a friend's house and we're actually going to run some material. I'm going to go ahead and mix up some dirt, but I wanted to just show you I've got about 10 pieces of gold that are 12 mesh or smaller, and then a bunch of fines that are 50 mesh and smaller, probably all the way down to 200 or so. It's just everything, all this fine gold I had that went through a 50 mesh screen. I'm going to mix that up in some dirt, and we're going to go ahead and then run the dirt, take everything that gets discharged from this as well as what goes into the tubs, and rerun it through the gold cube when we're done to see how efficient this is, and hopefully very little, if any, gold. Probably a little bit of the fines may end up in being caught by the gold cube. But that's what we're going to do today. I wanted to just take a minute and describe the principle and how this works. There's more thought that goes in this than initially meets the eye. I'm running a Harbor Freight 1,000 gallon per minute pump, which when it bucks a 2.5 foot head, I'm probably putting out about 13 gallons per minute. The principle and how this works is the PVC pipe, that's a 2 foot horizontal section, actually just acts like bedrock. There's no matting in there. There's absolutely nothing to capture the gold but the little bit of black sands and gravels that would accumulate on the bottom during the operation. Probably about a cup to 2 cups settles out on the bottom during operating, and it will capture the gold and provide a little hiding place for it to get out of the flow stream so it won't be picked up, come up this vertical leg, and be discharged into the sediment tubs. It's surprisingly efficient as long as you have a place for the gold to get to the bottom and hide. You don't really need all that fancy matting. This is a very inexpensive to build. The only reason I have these rubber couplings, by the way, here is to allow for me to be able to turn the discharge in depending on how I have my tub set up. Ideally, this will process up to 1/4 inch material. However, today, because the gold cube only handles 1/8 inch material or less, I've classified all the dirt that we're going to be putting in here down to 1/8. At ideal operating conditions are just to have enough pump rate to lift out the 1/4 inch or 1/8 inch largest non-gold particle of quartz. That's 2.65 specific gravity. As long as you have enough flow rate or velocity in the pipe to lift that out, the gold will settle to the bottom and not be picked up back into the flow stream and discharged. Physically, I've even gone through settling velocities for gold, even accounting for their shape factor, and you can go Google. The velocity of gold settling is dependent on the degree of flatness, which is the Corey shape factor. That's C-O-R-E-Y. And using the average shape factor of 0.25 and calculating the velocities, even at a high rate. Today I'm not going to hook on a pump controller, motor controller. I normally try to run my pump at about 10 gallons per minute. At 10 gallons per minute, that's all I need to lift out the 1/4 inch pieces of quartz and rock and still leave all the gold behind. Today I'm actually going to be running a worst case scenario. I'm going to be running my pump without being slowed down at a full 13 gallons per minute. I'm going to break here for a second or two while I mix up that gold in the dirt, and then I'm going to come back and start running it. The nice thing about this system too, as I start feeding the dirt, is unlike most sluices, you can start this thing, stop it, start it, stop it. You won't have to worry about the change in water velocity going over the edge of the sluice interfering with washing gold off the edge of the sluice. In here, the gold stays in the bottom. Start it up, stop it, start it up, stop it. Won't have any impact at all at losing gold. A much nicer feature. It's easier to clean out. than a conventional sluice. There's no mats to mess with. You don't, and the ideal operating condition is you have enough water in this mixing hopper so that you're not getting any bubbles. You want it, and that's why I have an opening on top. I could just have a 90-degree elbow. I wanted to make sure I could look down in there and see I have very little or no air. So you want your inlet from your pump into the hopper to be below the working operating fluid level, so that you don't minimize or eliminate any and all air. Ideally, you could be doing this by a creek or a river and eliminate all the recirculating tubs. You can set those up any way you want, but man, it's really nice if you have a river or a stream and eliminate those tubs. You can feed this thing at a pretty good rate. Since the dirt is all being immersed in water, you don't really have to have the material wet before you add it. It can be perfectly dry or wet, either one. And the other advantage, as I said, over the Gold Cube is you can actually, if you're running up to 13 gallons per minute, you can run material that's 3/8 inch in diameter. So if you're in an area that has larger nuggets, you might not lose it. If you're running at 10 gallons per minute, then you probably want to classify down to 1/4 inch. The velocity that you're actually pumping water through this thing, ideally to lift a 1/4 inch nugget, you need a little over 1 foot, or right about 1 foot per second is the water velocity moving through this PVC gold trap. I'm hoping today this will be the first test of gold below 50 mesh. I'm speculating and hoping that maybe I'll catch approximately 80% of it or so. This will be the first test I'm looking at minus 50 mesh recoveries. And for that, we're going to run everything against the Gold Cube. The last GPAA magazine showed the Gold Cube is able to get virtually 98% or thereabouts of gold recovery from 50 mesh down to 200 mesh. So I'm going to use that as my fine gold classifying standard. Now I'm going to go ahead and shut off for a minute. Would you peek through the screen, make sure I'm getting everything in the picture I need to? And I'll go ahead and continue feeding that last bucket of material, just so this YouTube video isn't too long. And I'll show you the clean out when I'm done adding all the material, how easy it is. This is my first YouTube video, so I'm hoping this is all going to work out okay. I've got another tub like this to add. I'm just about done with this one. This was probably a total of about 3.5 gallons of material. If you're running 1/4 inch material, you might have to slow down the feed rate a little bit. It will, because it's basically a giant U-tube, it will plug up just like a toilet would if you fill it up too fast. If you see this fluid level starting to rise in your hopper, you immediately back off and slow down your feed rate. It's just a little bit of a learning experience, and it's not anything difficult to master. I've got this other tub to run, and I'll run it and then join you again for the clean out. Thank you.
Hello, we're back again. What I'm going to do now is show you the cleanup. Just going to go ahead and remove the pump hose, and the object is to just go ahead and slowly drain out a little bit of the water. Then we're going to tilt it and collect the concentrates. Just pour off a little bit of water. Pour it out slowly. I'm just going to shake it a little bit, loosen up the, during a break, went to lunch, so the material sat there for a little bit. Now just tilt this thing up in the air. Don't know if you can see it. Got a rubber cap over the edge of the pipe with a hose clamp. Just going to take it off. There's a little bit of dirt in the edge. Now we go ahead and just pour the water out. And I forgot to tell you earlier on, when you glue this thing together, one place you don't want gold traps is in this PVC pipe. So for these connections, before you glue them up together, what I did is I did a perfectly 90-degree chop with a radial arm saw. Then I took a file and I beveled the edges on the pipe, so when I glued them together there was no gap. Because what you need is a nice way to be able to take a little bit of water. You want to be able to get the gold out of the trap. So you just pour a little bit in and rinse out the gold. Basically all there is, and your gold trap is clean. Just making sure my test cap doesn't have any gold on it. Put it back together and you're ready to go again. No mats to clean out. Nice fast clean out, and I'll pour off some of this water. And you can see we've got maybe a couple cups worth of material. We're going to go ahead and pan this. I'm going to pan that right across the way. In this other tub where we still got some clean water. I know I'm a little far away from the camera, but I'll bring it over there in a minute. I still have quite a bit of black sand. Fan a little bit of that out. Might ask my partner to pick up my camera and move it closer to me here so I can show you. Set it right there if you would, please. Can you see the gold through there?
It's in a shed.
Let me try to move this a little bit to get it in the sun. And I'm going to continue swirling. You can see it has picked up an awful lot of the fine gold. I know I'm moving a bunch of it down in the bottom of the pan, but I just wanted to show you that for a few bucks in PVC pipe, you can make yourself pretty decent little gold trap. And it's pretty efficient. What we're going to do now, and the next step is I'm going to take the time to collect all of the sediments that are in the black tubs from running the PVC 2-inch gold trap. And I'm going to take all that sediment and we're going to run it through the gold cube, pan it, and see how much gold, especially the fine gold, ends up. Hopefully very little. Again, this is my first test of the PVC gold trap versus the gold cube. So I'm going to pause this. We're going to go ahead and run everything through the gold trap, and I'll turn it back on again when we get the cleanup time from the gold cube. Alright, I had a possible operator error, so I'm reshooting this last segment. We panned everything that came out of the gold cube, which was all the material that was in the black mortar mixing tubs that was discharged from my PVC gold trap. And you probably won't even be able to see them, but I probably did get about 20 little microscopic colors that went through my PVC gold trap that came out and caught by the gold cube. It's either that or my fellow prospecting buddy who I borrowed the gold cube from didn't clean it out real good, and I maybe picked up some of his gold. But anyway, the amount of gold that ended up going through this PVC trap compared to what was caught, I went ahead and cleaned up the gold that was caught in the gold cube, in my PVC. In the PVC trap, and I'll just fan this out so you can see it. The PVC trap did catch all the 10 large 20 mesh to 12 mesh. I had 10 little particles of gold, and then there's just a whole pile full of -50 mesh. On a by weight percentage, I'm saying the PVC 2-inch gold trap probably caught 95% of the gold below 50 mesh. It caught virtually all of the gold above 50 mesh. So if you want to have a little fun with your family, just to repeat, and you're a do-it-yourselfer in your garage, you can go ahead and make this PVC trap for probably 25 bucks or so, 30 bucks worth of PVC materials. Buy your tubs, 1,000 gallon per hour 12-volt bilge pump. Put it together. Again, don't forget to bevel the joints so there's no gap, especially on that bottom horizontal run. This horizontal run, you also want to make sure you at least have 2 feet long. I've gone through the calculations, and a minus 50 mesh piece of gold conceivably only would travel about 9 inches before it would settle 2 inches from the very top of the pipe to the bottom. So that's why I made it 2 feet long, just to give me a little extra safety factor, to make sure most of the gold has a chance to settle out of the flow stream onto the bottom of the PVC pipe. So the advantages again to this over a conventional sluice: super easy clean out. You can start, you can stop, you can start, you can stop to your heart's content. You don't have to worry about washing gold off the end of your sluice. It requires a smaller pump size than a lot of your recirculating sluices. Again, that's a 1,000 gallon per hour pump. And ideally, again, your optimum pump size for this is, or pump speed is 10 gallons per minute for 2-inch. It could be scaled up to 3-inch or 4-inch. You just have to go through the calculations again. Optimum velocity is about 1 foot per second. That will lift -4 mesh non-gold, essentially quartz material out. You don't want to pump any faster than that, because all you want to do is pump fast enough to lift your largest piece of quartz out and let the gold stay to the bottom. If you'd rig up a big pump on this thing, yeah, you're going to blow out the gold. You don't want to do that. There is some science in matching the size of the pump versus the diameter of the pipe. But conceivably, you could scale this up to 3-inch or 4-inch. If you went to 4-inch, you'd probably be talking 40 or 50 gallons a minute for pump speed for 1/4-inch material. Advantage over the cube: this can handle, actually, running this pump, I could probably put through 3/8 inch and minus material, although most of the time I just run 1/4-inch. The larger material, you do have to be a little more careful in feeding it through. It does take a little longer to work its way out of the system. Anyway, hope you enjoyed the video. Hope to see a bunch of these out in the field. Thanks. Have a good day.